One method for adding vector is what we call the tail-to-tip method. For example, if we are trying to find the vector resultant R that's equal to A plus B plus C plus D, the way we get the sum is by starting with vector A. It's vector A. You see the arrow for vector A. So we draw it in any position we want. Once we draw vector A, at the tip of A, we draw vector B. It's important, at the tip of A, we draw vector B. Now, the order is not really important. We could have started with B and then gone to A. But anyway, the method, at the tip of one, you place the tail of the next one. Now, at the tip of B, the tail of the next one. In this case, the next one is C. So here we have the tail of C at the tip of B. And then the fourth vector in the sum here is D. We place it, of course, at the tail of the last one, which is C. At the tip of the last one, which is C. So the tail of D, we place it at the tip of C. Now we get the sum of the four vectors by joining the tail of the first vector in the sum, the first vector that we used in the sum. What's the first vector we used in the sum? It's A. So we look for the tail of A. We join the tail of the first vector to the tip of the last vector in the sum. The last vector in the sum is vector D. And this is its tip. So we join the tail of A to the tip of D by drawing an arrow. That's my vector sum, the vector R, joining the tail of the first to the tip of the last. That's why we call it tail-to-tip method. Now, how do we quantify this? Of course, we are assuming that we drew all of our vectors to scale. We used rulers and a scale to measure each one of the vectors. So the vector A here has a larger magnitude than the rest. And for directions, we assume that we used protractors to draw them in the right direction. So then, to get vector R, we have to take a ruler, measure its length, use the scale to find what R is equal to, and then use a protractor and measure the angle as well. Now here I have three simulations that you can use to play with this. In the next screen, I will play with this one here. You can have more fun with the other two if you want to. Okay, so let me pull it in. Okay, here's the simulation. We have three vectors, a blue, red, and green. And we're going to try to add them using the graphical method. So we press start. That adds for us the magnitudes and the directions for each of the vectors. Now in this particular case, it's just measuring the angle for us. It's not really reading the angle relative to the positive x direction. Anyway, so I can drag each of the vectors. So I'm going to start with the red one. So I'm going to position it anywhere on the screen, and then come with the blue one and position it at the tip of the red one. And then I come with the third one and position it at the tip of the second one. So my vector sum should be from the tail of the first one to the tip of the last one. Okay, so let's take this R here. We put it here at the tail of the first one, and then we join the tip of the last one. Then in this particular case, it calculates for me my vector sum R. It says that the magnitude is 4.4 and the direction, the angle is 1.95 degrees. Now, note this. If I add the magnitudes 6.09 plus 4.53 plus 376, that does not add up to 440. If I add up the angles, that would not add up to the 195 or the 440 either. 34 plus 34 plus 52. Even if you kind of play with the signs of the angles here, that's not going to work out. So to add vectors, you cannot simply add magnitudes or angles. In this particular case, we added them graphically. We'll learn later on how to add them mathematically. Okay, now just to verify, let's swap the blue vector with the green vector. So red, then green, then blue. You notice I still get the same sum. That's telling me that the order is not important. I can try something else. I can start with the blue. At the tip of the blue, I can put the red one. And then at the tip of the red one, I can put the green one. Now let's check if the sum will match. And of course it does. So the order is not important. But start with the first one. Tip of the first one, you place the tail of the second one. Tip of the second one, you place the tail of the third one, and so on. And then you get the sum by joining the tail of the first one to the tip of the last one. And then you use your scales and protractor to take the measurements of magnitude and the angle for the direction. That's the tail to tip method.